Hello, dear math buddies! Welcome to my YouTube channel, and thank you for watching my content. For today's video tutorial, I'll be providing more examples on how to simplify radical expression. But before I start, make sure to subscribe and hit the notification bell to be updated with my latest content. Likewise, I'll be more glad if you will like this video, leave a comment, and share with friends. Please do like and follow my Facebook page, Sherwin Math Tutorial, for more math lessons. Hello, dear math buddies! My name is Sir Sherwin, and I will be your math instructor. As what I mentioned earlier, this video tutorial will provide more examples on how to simplify radical expression. In my previous content, I discussed already the different ways on how to determine a radical expression that is simplified. Likewise, I discussed in that video tutorial about the different laws of radicals that is very essential in simplifying radical expressions. This time, allow me to add more examples on how to simplify radical expression for you to understand this math lesson. Let's begin. This time, let's try to simplify square root of 98. From this given radical expression, we can identify that our index is 2 and our radicand is 98 with its exponent of 1. At first glance, you can say that this expression is already simplified since the exponent is less than our index. But bear in our mind that still we can look for possible factors of 98 where one is a perfect square and the other factor is a non-perfect square. So we will think of possible factors of 98. So you can probably say that it would be 7 times 14 and 49 times 2. Both pairs of factors will give us a product of 98. But which between these two will be used to simplify our radical expression? So 7 and 14 doesn't have a perfect square. So we will use the second pair, which is 49 times 2. So square root of 98 can be written in the form as product of factors 49 times 2. So applying the product rule of our radicals, this can be written as square root of 49 times square root of 2. To simplify this expression, we will make 49 into exponential form. Since it is a perfect square, we can write this one as 7 squared. Then we will simply copy square root of 2. In our first law of radicals, if our index and exponent is the same, then we can cancel this out, leaving our coefficient, which is 7, and we will simply copy the radical square root of 2. This means square root of 98 can be written in its simplified form as 7 square root of 2. So this is how to simplify our radical expression. This time, let's try to simplify cube root of 40. From this certain expression, our index is 3 and our radicand is 40. Applying the product rule, we will think of the possible factors of 40. Take note, in identifying for factors of 40 to simplify this expression, we will think of a possible factor where 1 is a perfect cube for the reason that our index here is 3. So again, we will think of a possible factors of 40 where 1 is a perfect cube and the other is a non-perfect cube. So there are different factors of 40. So if we are trying to list down the possible factors of 40, we will have 4 times 10, we have 2 times 20, we will have 8 times 5. So these are possible factors of 40. But among these factors, which of them does have factors where one is a perfect cube and the other is a non-perfect cube? From our first pair, 4 and 10, 4 is a perfect square and 10 is a non-perfect square. So we cannot use this one as our factor. On the second pair, 2 times 20. From this certain pair of factors, there is no perfect square, there is no perfect cube. So again, we cannot utilize these factors to simplify our radical expression. While on the third pair of our factors, 8 and 5. 8 here is a perfect cube, while 5 is a non-perfect cube. 8 is a perfect cube because it is a result when we raised 2 to the third power. That means we will multiply 2 by itself 3 times. So, from this set of factors, we will use this one to simplify our radical expression. So, cube root of 40 can be written as cube root of 8 times 5. So, we will have to apply the product rule. That is cube root of 8 times cube root of 5. Then we will make this expression an exponential form. So we will have cube root of 2 cube and copy the second radical, which is cube root of 5. So from this certain step, our index and exponent is the same, so we can cancel out the radical symbol. So we will have 2 and copy again cube root of 5. So this means cube root of 40 can be written in its simplified form, and that is 2 cube root of 5. So this is how to simplify our radical expression. This time, let us try to simplify 4th root of 8 over 81. Applying the quotient rule, this expression can be written as 4th root of 8 all over 4th root of 81. From this certain expression, we need to rationalize our denominator. When we are talking about rationalization, it is the process of eliminating the radical symbol in the denominator. But how will we do this? First, let's try to look at our given radicals. Is 81 a perfect number, which is a perfect fourth power of a certain number? Let's try to find out. So, from this expression, we can say that 8 is a perfect cube. So, we can have this one written as 4th root of 8. While 4th root of 81 can be written as 4th root of 3 to the 4th power. For the reason that 81 is a result when we multiply 3 by itself 4 times. From this sample, we notice that our index in the denominator is the same as to the exponent of our radical. This means we can eliminate our radical symbol. So we will have 4th root of 8 all over 3. From this expression, we will have this one as our final answer. So 4th root of 8 over 81 is the same as 4th root of 8 all over 3. So this is how to simplify our radical expression. This time, let's try to simplify cube root of 1000 x to the 6th power y to the 5th power. From this expression, our index is 3 and our radical is composed of terms 1000 x to the 6th y to the 5th power. We can simplify our expression by writing them as cube root of 1000 times cube root of x to the 6th power times cube root of y to the 5th power. And that is through the idea of product rule. Then, we can write 1000 in its exponential form since 1000 is a perfect cube. So we can write this one as 10 cube. This means if we will multiply 10 by itself 3 times, that leads us to 1000. So 10 times 10, that's 100, times 10, that is 1000. Likewise, we can also write x to the 6th into an exponential form applying power of powers, where it is raised to the 3rd power. This means we can write cube root of x to the 6th as cube root of quantity x squared raised to the 3rd power. For the reason that we will eliminate our radical symbol with index of 3. While cube root of y to the fifth can be written as cube root of y cubed times y squared. And that is applying product of a power. So, we can eliminate our radical symbol since the index and the exponent of the radical is the same. So, we will have to copy 10 as our coefficient. Likewise, we will eliminate our radical symbol since our index and exponent is the same, leaving x squared. On the other hand, in the case of cube root of y cubed times y squared, that is written in the form cube root of y cubed times cube root of y squared. So we can also eliminate our radical symbol since our index and exponent is the same, and leaving cube root of y squared inside our radical symbol since our exponent here is less than the index. So the terms that is outside our radical symbol are composed of 10, x squared, and y. While the term that is inside our radical symbol is cube root of y squared. So this means we can simplify cube root of 1000 x to the 6th y to the 5th power as 10 x squared y cube root of y squared. So this is how to simplify our radical expression. Let us try to simplify our next radical expression, and this is cube root of 1/9. So applying the quotient rule, this expression can be written as cube root of 1 over cube root of 9. So it is indeed very important for all of us to remember that a radical expression is simplified if and only if there is no radical symbol in the denominator. From this certain expression, we have cube root of 9. So how will we simplify this expression? In this given radical expression, the idea of rationalization will take place. Again, when we are to define rationalization, it is simply process of eliminating radical symbol in the denominator. So we will think of a possible number to be multiplied to 9 to make it as a perfect cube. So let's try to simplify. So cube root of 1 is equal to 1, and again we will have cube root of 9. So since 9 is a perfect square, so exponentially we can write 9 as 3 squared. So we will try to write this one as 1 over cube root of 3 squared. So applying the product of a power, we will think of a number to be multiplied to 3 squared to make it 3 cubed. From this certain step, we will think of a number, and that number is cube root of 3. So it will be multiplied both in the numerator and in the denominator. Why I choose cube root of 3? Because applying the product of a power wherein we will be adding the exponent of our radicand, that leads us to a sum of 3. This means if we will simplify this expression, 1 times cube root of 3, our numerator is cube root of 3. While our denominator is cube root of 3 squared times cube root of 3, wherein we can simplify this expression by adding the exponent of our radicand. So that is through product of a power. So that is 3 cubed. So we can eliminate now our radical symbol because our index and exponent is the same. So we will have to write cube root of 3 all over 3. So this means simplifying cube root of 1/9 is equal to cube root of 3 all over 3. So this would be our answer. There you have it. Hope you learned something new today. God bless us all.